Hi everyone, welcome to Module 15 or SRWE course, which is going to deal with IP static routing. There are so many different ways to dynamically route a packet that you might wonder why anybody would take the time to manually configure a static route. Let me give you a simple analogy to understand this. Now, who would usually wash their clothes manually by hand when we have a pretty good washing machine? But we are all aware that not all the clothes go into the washing machine. Some of the items are best washed by hand. In the similar manner, pretty much in the same lines, there are situations where a manually configured static route is the best option. There are different types of static routes, and each is perfect for solving a specific type of network problem. Many networks use both dynamic and static routing. So network administrators need to know how to configure, verify, and troubleshoot static routes. If your objective is to become a network administrator, or even if you want to improve your existing administrator skills, then learning this module is going to benefit you a lot. So let's get going. So these are the different topics that we are going to cover as part of this module, which we will discuss about the command syntax for setting up the static routes. How do you configure IPv6 and IPv4 static routes, default static routes, and what is the need for a floating static route, and how do you configure it to provide a backup connection? And then we will also discuss about configuration of IPv4 and IPv6 static host routes that direct traffic to a particular or a specific host. So let's first things first, let us start with what are static routes. So static routes are commonly implemented on a network. This is true even when you have a dynamic routing protocol configured on the network. The static routes can be configured for both IPv4 and IPv6 networks as well. There are 4 different types of static routes based on the way that they are set up, which includes the standard static route. The second version is something called as default static route. The third one is a floating static route, and the fourth one is a summary static route. All these static routes are actually configured in your global configuration command using the IP route or IPv6 route commands. We discussed this in our earlier video as well, but let me show you with some examples. So whenever you configure a static route, the next hop can be identified either by an IP address or an exit interface or even both. So how are you going to specify the destination actually creates one of the 3 following types of static routes. There are 3 types. The first one is called as a next hop route. Here, only the next hop IP address is specified in your command. Now, the second one is something called as a directly connected static route. Here, what we do is we only specify the router's exit interface. That means through which the packet should be sent out. The exit interface of the router only will be specified. If we specify both the next hop IP address as well as the exit address, then we call it as a fully specified static route. These are the 3 variants. So the way how you configure, if you want to give just the next hop IP address, or if you want to give the exit interface on the router, or if you want to give both, then based on the type of information that you are providing, we can have either of these 3 static routes, 3 types of static routes. So this is the command through which we use it. So IPv4 static routes are configured using the common command. So IP route, and then you give the destination network address followed by the subnet mask, and then this is the next hop's IP address followed by the exit interface or even the IP address. This distance is an optional command which will allow you to set up the floating static routes, which will be discussed in the later part of this module. IPv6 is pretty much similar to what we do. There is not much difference, except for the fact that rather than giving the subnet mask here, we give the prefix length. All the remaining ones remain the same. So whenever you want to configure a static route, you need to mention this command IP route or IPv6 route, then the destination network address along with the subnet mask or the prefix length, followed by either the IP address, which is nothing but the next hop's IP address, or the exit interface, or even both, doesn't matter. So let me show you one simple topology where we can implement these routes so that we will understand better. This is the topology. So please remember that in this topology, R1 has 2 directly connected networks, right? So R1 has 2 directly connected networks, which are 172.16.3.0 is one directly connected network, and the other network is 172.16.2.0. So these are the two directly connected networks. Whereas with respect to R1, there are three remote networks. The three remote networks of R1 are 172.16.1.0, 192.168.1.0, and the third one is 192.168.2.0. So these three are remote networks when you compare it with R1. So when you first set up R1, the routing table will only contain the entries which will have these two connected networks only, which is 172.16.2.0 and 3.0. And also it will show you the entries corresponding to the IP addresses configured for this interface G0 by 0 by 0. You can see this. The IP address for this is 172.16.3.1. Similarly, for this interface S0 by 1 by 0 is 172.16.2.1. So let me show you. Now, this is the starting routing table for R1. There is nothing we have set it up. So each router has entries only for the directly connected networks and associated local addresses. So R1 can ping R2 but cannot ping the R3 LAN. Now, because R1 can ping R2 because it has directly connected network with R2, but it cannot ping the R3 or R3's LAN. Now, let me show you. Now, when you type in the show IP route and begin gateway, because currently there is no default gateway set, it's saying that gateway of last resort is not set. And as I told you, we have these two, let me show you clearly. So we have the two networks which are designated by C, telling you that these are two directly connected networks, and the directly connected routes are there with the IP addresses matched. You can see that that is written as 32 here. The 32 tells you that all the bits need to match. Okay. And when you try to ping the R2, it is 100%. But when you try to ping the R3's LAN, the success is 0%. So this is how initially the R1's routing table entries are shown as. They only have the corresponding entries for the directly connected networks only. The same thing holds good even for IPv6 also. When you want to check the IPv6 routing tables, we need to type in show IPv6 route and begin see. You can see that these are the two directly connected networks here, 1 and 2, and both the local routes for IPv6 network are also mentioned over here. If you want, I can quickly scroll back. You can see that this is the IPv6 network address which are directly connected to R1, and similarly in this address we need to put it in as 1.1. That's all. Okay, so you can see this is what it is being shown here. Double colon 1, double colon 1. And once again, we can try to ping R2, which is success. And if you want to ping R3's LAN, it is a failure. So these are the starting routing tables, which only contain the entries of your directly connected networks. So let me show you how do you configure the static routes for R1 now. As I told you earlier, R1 has 2 directly connected networks and 3 remotely connected networks. So how do I configure the start? Let me see. Let me show you. So in the next hop static route, first I'm using the first variant, which is a next hop static route. So on R1, I'm specifying that. So these are my 3 remote networks for R1. So I'm specifying a way so that the packets which are destined for these networks should take this path. I'm showing. So I'm only specifying the next hop IP address. So this is the IP address of my next hop. Okay. So I simply need to put in IP route, the addresses of the 3 remote networks along with their subnet masks, and then finally the next hop IP address. So this is called as next hop static route. Now the resulting routing table entries are, you can see here, the first ones remain the same, but whereas the remaining 2, there are 3 here, 172.16.1.0, this is 192.168.1.0 and 2.0, and via. This is the next hop's IP address. If you remember this, 172.16.2.2 is the IP address of R2, this interface of R2. So this is my next hop address. So for all these 3 networks, my next hop IP address will be the IP address of this interface, which is S0 by 1 by 0 of R2, which is 172.16.2.2. This is the variant where I only specify the next hop's IP address only, right? So this is one way of doing it. You can see that now the routing table is updated. Similarly, for IPv6 also, I need to do the same. First, I need to enter IPv6 unicast routing, and then I need to put in IPv6 route, your address, and then followed by the next hop's IP address, IPv6 address. This is my next hop's IPv6 address, which is nothing but the IPv6 interface address of your R2. Now the routing table gets updated once I do this, because I set three static routes for 3 different networks. The same is being reflected in my routing table also. You can see here 1, 2, and 3. So 3 remote networks, 3 static routes, 3 of the entries in the routing table. Okay, this is how you do it. Now, if you want to do it in another manner, if you want to do a directly connected static route, what we need to do is we need to specify the exit interface that we are going to use to send the packet out. Once again, the same thing, we need to type in the IP route, give the 3 remote networks IP addresses or their network addresses followed by their subnet mask. But instead of giving the IP address of the next hop, here what I'm doing is I'm actually giving the exit interface. You can see here the exit interface for all these 3 remains the same. S0 by 1 by 0, S0 by 1 by 0, S0 by 1 by 0. If you remember, let me go back to my topology diagram. Yes, this is my exit interface. So if a packet comes in to any of these 3 remote networks, R1 knows that the packet should be sent out through this interface. S0 by 1 by 0. This is what it is mentioned over here. Okay. Let me scroll back. There you go. This is what. Now, once again, this also creates those 3 static route entries in my routing table. So earlier, I have shown you that this entry reflected the IP address of the next hop, but now it is showing only the exit interface, serial S0 by 1 by 0. The same thing holds good for your IPv6 also. So IPv6 also, I'll simply need to mention those 3 remote networks followed by the exit interface S0 by 1 by 0, S0 by 1 by 0, S0 by 1 by 0. Once I do this for IPv6, automatically my routing table will reflect those 3 entries that I just added as the static routes. You can see these are the 3 static route entries that are added into my routing table of IPv6. You can actually cross-verify them by using the show command, whether these are added properly or not. And also please verify that these are all 1 by 0. 1 is your administrative distance, 0 is the metric. We discussed this in the last video also. Now, the third variant of this particular static route is your fully specified static route. This means if you give both, you can see the similar things. Here, this is my remote network. This is my subnet mask. And then we give the interface and the IP address of the next hop. This is how you do it on R1. If I want to specify, if in a fully specified static route, both the exit interface and the next hop IP address are specified. Here I'm specifying both through what I need to go. Now, the next hop must be directly connected to the specified exit interface. Using an exit interface is optional, but it is necessary to use a next hop address. It is recommended when the exit interface is an Ethernet network that the static route includes a next hop address as well. You can also use a fully specified static route that includes both the exit interface and the next hop address. This is how you need to mention the interface as well as the next hop's IP address also. This is how you do it. This is called as a fully specified static route. So both the things are mentioned. The same thing holds good for your IPv6 also, but except for one difference. The thing is, when you want to do a fully specified static route, and if you want to mention the particular link local address, it will not take the link local address. So for this, you have to mention a fully specified route only. There is a situation in IPv6 when a fully specified static route must be used, because you cannot simply use this link local address. The problem for that is the link local addresses are only unique on a given link or network only. You can't simply say FE80:2. You got to mention the exit interface as well as the link local address of the next hop. So these 2 things must be maintained for IPv6. So this is an example. Now you can see once you do this, this is how it is shown as. On your R1's routing table for this particular topology, it shows that this is the static route via and what is the exit interface. This is my exit interface. I can't simply use this F80:2 only, or giving only this option or giving only the link local address of the next hop's IPv6 address will not work. I need to mention the exit interface also. This is for IPv6. Thus, it does not have a big deal on IPv4 because IPv4 you can use both. You need to use the exit interface as well as for a fully specified static route, the exit interface as well as the next hop's IP address. How do you verify static routes? Once again, there are a lot of show commands. I've given you some examples over here. I am showing you some of the examples where how we use the show commands to verify whether everything is working fine or not. Are there any errors, or even for troubleshooting also. The most commonly used ones are the show IP route static. You can see if I type in show IP route static begin gateway, it is showing to me that gateway of last resort is not set. The last resort is not set, as well as I have seen that there are 3 static routes SSS. Similarly, show running configuration section IPv6 route. So if I want to see whether I enter the addresses without any errors or not, I can use this show running configuration section IP route. This is for IPv4 addresses. Show IPv6 route. So it is actually showing to me all the routes here, all the routes that are configured into your table. So these are the different show commands. If we want to use the same for IPv6, just replace IP with IPv6. That's all, nothing else. So we have been using this for quite some time now. I hope that by now you must have mastered the use of show commands and also to play with the show commands output by using the pipe section and the other things like section beginning through. Okay. So how do you configure the IP default static routes? Now, what do you mean by static route? A default route is a static route that matches all packets. So I told you about static route is nothing but a route that is manually configured by a network administrator to reach a remote network. Then what do you mean by a default static route? A default static route is one which matches all packets. That means that if a router receives a packet which or whose destination IP address is not found in the routing table, so the router does not know what to do with it. It does not match any of the routing table entries that are present inside the routing table. What does it do with it? In that case, this is used. We can set a default static route so that the router forwards it on one particular interface. Okay. Now the routers commonly use default routes that are either configured locally or even learned from another router. So the default route is used as the gateway of last resort. That is the reason once we specify this, it will show you that gateway of last resort is set. Anyhow, we'll see in the routing table entries. Okay, so default static routes are commonly used when connecting an edge router to a service provider or even a stub router. I spoke about the stub routers in my earlier video. I told you that stub routers are one way with only one upstream neighbor router. You can see here, R1 is a stub router because it has only one neighbor only, which is R2. There is only one way to enter into this network or to go out of this network. So this network is called as a stub network and this router is called as a stub router. So we can actually specify default static route so that all the traffic coming out of this network has to go to the R2 only. Okay. So this figure is the one which actually shows a typical default static route scenario where we can set up a default static route. So how do you do that? Now for that, first let us talk about IPv4 default static route. And the command syntax for IPv4 static route is similar to the same static routes that we used, except for the fact that the network address and the subnet mask is all zeros. You can see it is all 0, 0.0.0.0, 0.0.0.0, and then you specify the next hop IP address or the exit interface. Now, if you ask me why are we specifying all zeros, you have to remember that this particular packet or the destination address need not match anything. So if there is no match in your routing table entry, automatically the default static route will come into play. So this is also referred to as a quad zero route. Quad zero route. So this is the basic command syntax for issuing an IPv4 default static route. We mention all zeros. Similarly, the same lines we have to do for IPv6 also. IPv6 we mention like this, all zeros, :/0. The prefix length is also 0. And then you mention the IPv6 address of the next hop or even the exit interface. So this is how you set up the default static route. So let me show you. Now in this example, once again, if I want to set up on R1, what I'm doing is I'm setting a default route for 172.16.2.2. So if R1 receives a packet which it doesn't understand or which does not have a good match at all in the routing table maintained at R1, then I'm specifying that if you don't have a match, forward them to 172.16.2.2, which is the IP address of this interface. So similarly for IPv6, If I get an IPv6 packet with the destination IP address not matching any one of my routing table entries, I'm specifying that you need to go into this. You can see this. This is the IPv6 address of this particular interface of R2 S0 by 1 by 0. This is called as a default static route. So how does this appear in the routing table? How does it differ from the static routes that we just mentioned? Now you can see here, there is a star. There is an asterisk. So the show IP route static command output from R1 displays the contents of the static routes in the routing table. Note the asterisk next to the route with code S. The S says that this default route has been configured manually. Of course, you might get a default route through dynamic routing also. It might be designated by 0 star, O star. So O star tells you that this is a default route, but it is learned through using the dynamic routing protocol OSPF. So the asterisk indicates that this static route is a candidate default route, which is why it is selected as the gateway of last resort. You can see here, the gateway of last resort is set as the IP address or the next hop's IP address that you specified to network 0.0.0.0. Because as I told you earlier, the /0 mask for IPv4 routes, it is simply that none of the bits are required to match. When a router has to make a decision, it has to see that how many far leftmost bits of the destination IP address matches with the routing table entries present in its routing table, right? So when I specify /0 or the prefix length is 0, it means that none of the bits need to match. And if there is no other specific match in the routing table, that packet will be sent across this particular default static route. As in simpler terms, I'm saying to the router that fine, if you don't have a match for the destination IP address of an incoming packet, if you don't know what to do with it, you simply forward to this particular next hop IP address. That's all. Your job is done. This is how you specify net. And also, once again, if you want to verify whether the static route is set or not, you can simply type in show IPv6 route static. This is the IPv6 version of it. Okay, so this is the IPv6 version of it. You can see that it is shown over here. Once again, we are using the /0 prefix, which tells you that none of the bits need to match. So let me move on to the why do we need to configure a floating static route? So what do you mean by a floating static route? It is simply, it's a backup route. If at all your original static route fails, that's all. So this is another type. So these routes are static routes that are used to provide backup path to a primary static or a dynamic route. If something goes wrong, then automatically the floating static one will act as the primary. It is only used if the primary route is not available. If the primary route is still working, the floating route will not be used at all. It will not be seen even in your routing table. So to accomplish this, how do you set it up? The floating static route is configured with a higher administrative distance. As I told you in my earlier video, administrative distance plays a crucial role in the router selecting which particular route to be updated in its routing table, right? So when I have a administrative distance maybe of 1, and if I set a floating point or a floating static route with an administrative distance of 5, only the primary will be kept in the routing table. The floating static route will not be kept in it. If the primary fails, then this particular floating static route will come into play because it has the next least administrative distance. Okay. And because the administrative distance represents the trustworthiness of a route, the lower the administrative distance, the highest the trustworthiness it is. So by default, static routes have administrative distance of 1, making them preferable to routes learned from dynamic routing protocols. Dynamic routing protocols usually have an administrative distance of 110. I have shown you the table also in my earlier module. So this is how you use it and how do you specify it. Okay. So the way the technique behind this is the static route floats and is not used when the route with better administrative distance is active. Only when the primary phase of something happens, then this particular floating static route comes into play. Now you can see here, how do you set it up? You can see this. So IP route 0.0.0, 172.16.2.2. This is your primary static route, right? Now, I'm afraid that I might have a situation where this next hop IP address is no longer going to be available for me, or something might happen. So I'm writing in my second command, I'm setting up this as my floating static route. So that IP route 0.0.0.0, I'm specifying a new next hop address and I am also specifying an administrative distance of 5. Because here the administrative distance is 1, this is always preferable. But if this fails, I'm showing that there is another path, then you select this. The same thing holds good for your IPv6 also. For this, the administrative distance will be 1. But here for this static route, the administrative distance, or this floating static route, the administrative distance will be 5. So as long as this path with an administrative distance of 1 is active, this will not come into play. You can see here at the earlier stage, when you try to see type in the show command, show IP route static, the first one is shown here, 172.16.2.2. Even for IPv6 also, the first path only will be selected. This only will be selected. But just if you check out a scenario where R1, R2 shuts down both of its serial interfaces, if these two interfaces are gone down, then you can see here, if I'm setting it as the gateway of last resort, now the second route which I set it up, 10.10.2 comes into play. You can see the default static route has changed now, and the administrative distance as 5, because I mentioned 5 in my command structure. So this is how it is used. This is how the floating points are used. And similarly for IPv6 also, the administrative distance is shown as I, and the floating point, the floating static route has now become the primary route. Please remember that as long as the primary route is functioning, the floating static route won't work. It will not be updated into the routing table. Only the first route will be updated, because by default, or the static routes will have an administrative distance of 1. So that is why when you want to set up your floating point or floating static routes, you have to specify the administrative distance of more than 1. Okay. So then we move on to the configuration of your static host routes. So what do you mean by static host routes? You know that a host route in an IPv4 address is with a 32-bit mask. We studied this in the earlier module as well. And for an IPv6 address, it's a 128-bit mask. So the following shows the 3 ways a host route can be added to the routing table. The first one is they are automatically installed whenever a router's interface is configured with an IP address. The second way is when you configure a static host route, when you specifically mention it. The third one is it is automatically obtained through other methods like your dynamic routing protocols. So how do you do that? How do you configure? Now, whenever you see the routing table entries, you see that there are some indicators C and L, right? So in connection to the connected route or the directly connected networks, you can see an L at the bottom or in the next entry, which will tell you that this is a local route. So a local route is nothing but which specifies the IP address assigned to that particular interface, which is connected to that particular network. Okay, so a host route allows for a more efficient process for packets that are directed to the router itself rather than for packet forwarding. So this is how you use it. These are all automatically installed. Whenever you type in the, let us say if I want you to configure R1, you will type in interface Z0 by 0 and then enter. You will give the IPv4 address and then you will give the IPv6 address and then you will type in no shutdown. So whenever you typed in no shutdown, the interface will get active now. So automatically in the routing table entry, these 2 routes will be added as the directly connected networks and also the local route indicated by C and L entries in your routing table. Now, this can also be manually configured route to direct traffic to a specific destination. Now check this diagram in the shown. So the static route uses a destination IP address and a mask of 32. I'm saying that if any traffic that is destined for this particular server 209.165.200.238, this is the server. I want to direct traffic to this. You can see. So IP route, this particular IP address or the destination host IP address followed by the subnet mask. Here I'm giving you all the 32 bits, right? That means that everything should match. All the 32 bits must match, identical. That means the destination address should match. Then please forward this on to the next hop address, which is 198.51.100.2, which is this interface. So on the branch router, I'm configuring, if at all the traffic needs to go on, or if we receive a packet with the destination address which is equal to the server or which is identical to the server, forward all the traffic to this interface, which is the interface IP address of the ISP's router. Similarly for IPv6 also, I can specify this. I am also specifying that all 128 bits must match. And then we forward it on to this is all set up in the branch router. I'm setting this static host routing in the branch router, telling it that any packets which are to be sent to the server, please forward it on to this particular next destination address. Okay, this is how you set it up for static host route. Now, how do you verify? Simple, straight away, show IP route, begin gateway. You can see that another static route has been added into the R1s or the branch routers routing table. Similarly, for IPv6 also, you can see that the static routing is entered or enabled. So once you enter that command, you have to verify whether the static route has been enabled or not. Once again, you can see that the administrative distance is 1 and the metric is 0, which is the lowest. So always, but doesn't matter if there is another entry for the server also, this will be preferred. Now we come to the IPv6. Once again, with IPv6, with the link local addresses, as I just explained to you in the earlier slides, if we want to mention a fully specified static route for the next hop, you need to do this. You need to mention like this. I'll tell you. So, however, you must specify the original IP. In case when you want to configure an IPv6 static host route with link local address for the next hop. If I don't want to give the complete address, IPv6 address, I only want to give the link local address. In that case, the first thing you should do is you should remove it, the earlier one. We should remove the earlier set the static route, no IPv6 route and this particular address. And then I need to add in IPv6 route for this destination. All the 128 bits must match. And then this is my exit interface followed by the link local address. I cannot simply give the link local address alone. It will not accept. If I want to specify the next hop's IPv6 address as its link local address, I need to specify the exit interface also. If I don't specify the exit interface, it will not accept. This is because I told you earlier again, the link local address might be, or it might be identical only on that particular link or on that particular network. You can, so that you cannot simply use the link local address only. Now, if you can check out here, once I do this, once you go into the show IPv6 route, you can see that the new static route or the static host route is added for this particular destination. You can see this is the particular destination of the server, and it is showing that via FE80 link local address and the serial interface, which is nothing but the exit interface. So this is all regarding your static routing, static IP routing. How do you set up the static routes, whether you use the next hop IP address or whether you use the exit interface, or do you want to use both? What are the different configurations used for IPv6? How do you verify these things? Hopefully you understood this. This is a pretty simple module if you understand your earlier module well, because in earlier module we discussed about all the routing concepts and the internal functioning of a router, how to read the routing table entries. If you have a good grip on that, automatically you should have a good, you should now understand these things well. There is a packet tracer activity which allows you to work hands-on approach configuring all these static routes. So do check that out as well. Thank you very much for watching this video. Thank you.